All right, we got a little interrupted there with some technical difficulties. Had some freezing screen on me. Anyways, we're getting right back into it with question number 10 here. This is so easy, it's kind of ridiculous. It's mostly just understanding what the heck is this doing here. So it says f of negative 5, and the general idea there is that you see this negative 5, and it's really just saying that's your input. That's what you're going to plug in. So I see that f of x equals negative 5x minus 7, so f of negative 5 is going to be negative 5 times, instead of x, we're going to put in a negative 5 right there. And we got minus 7. So this would be negative 5 times negative 5, which is 25 minus 7 equals 18. There we go. Cool. All right, next. What do we got going? We got 3 times 12 plus 4z. This is, oh, what's happening here? Oh, this is just solving an equation. So easy. We love solving an equation. That's so much fun. It's so much fun. Really, it is. So let's see what we can do with it. There's a couple of things. You know, I could multiply both sides by 1/3. I could distribute this 3. A lot of stuff. I know a lot of times we like to ungroup these parentheses, and to ungroup them so we can move stuff around, we need to distribute. So that makes this 36, and then the 3 times 4z is 12z. So I got 36 plus 4z, or not 36 plus 4z, 36 plus 12z equals 24. All right, so I have all those things. Let's see what we got. 36 plus 12z equals 24. Now, a couple of things you could do at this point. We could either subtract that or divide. I'm actually going to do some subtraction. We could subtract both sides by 36. Then we'd have 12 equals negative 12z, equals negative 12. Well, that's pretty easy. That would tell me that z equals negative 1, because 12 times negative 1 is negative 12. Cool. I like this stuff. It's super easy. All right, let's look at the next one. It says solve and graph. So we got a couple of things going on there. I'm going to take some space here because this is actually going to use up way more space than number 13. So I'm going to take up kind of all this space here for number 12. Okay, so I'm looking at number 12, and it says solve and graph. There's a lot of stuff you can do with these inequalities. You can multiply, divide, add, subtract, just like you would with an equation. However, something else that's kind of interesting to watch for, whenever you multiply or divide by a negative, that's when stuff gets a little weird. You got to flip that symbol in the middle. Let's go ahead and start by distributing each side. Or actually, wait a second. I see something even easier. 6 times 3 plus 5x greater than 6 times 5x minus 2. In this case, if I were to divide both of these sides by 6, I would have 3 plus 5x is greater than 5x minus 2. That's kind of weird. That's really weird because all of a sudden now I have something happening with these 5x's in the middle. Because if I were to subtract 5x from both sides, I would have 3 is greater than negative 2. So this presents me with something interesting. I don't have any more x's, and it's telling me to graph this. Well, it says 3 is greater than negative 2, and when you're graphing something, a graph represents a solution set. And if I'm trying to do a solution set for this, 3 being greater than negative 2, I got 3 options. That's either always true, never true, or sometimes. And the sometimes is kind of not even in here because sometimes we'll have like an x in there. So that one's out. There's no x's. It's just 3 is greater than negative 2. That's always true. And if it's always true, well, then that tells me that I just have a graph that goes over every number. It's like shaded in the whole way, all across the number line. You might also see a solution that says something like all real numbers, all reals. That could be an option as well. And a lot of that is just because these variables, the 5x's, disappeared. Now the fact that we divided both sides by 6 to start and got 1 over here and 1 over there, that made no difference in reality. We would have come to the same conclusion in the end. 3 is greater than -2. All right, let's look at number 13. It says solve the proportion 2 over 8 equals x over 16. Okay, there's a whole lot of stuff you can do here. I'm really looking for equal fractions. An equal fraction would be like 1/2 equals 3/6. And I noticed that, oh, I just multiply both of these by 3 on top and bottom, which is really 1, and then I got 3 over 6. And I look at this one, and I say, well, 2/8, if I were to multiply that by 2 over 2, that would give me 4 over 16. So I'm guessing that this is a 4. And in fact, I'm pretty sure of that. But let me see if I can take it a little bit further. I think that I can even do some algebraic steps here. We got 2 over 8 equals x over 16. Well, if I were to multiply both sides by 16, let's see what would happen. On the right side, that would give me 16 over 16, or 1. On the left side, I'd have 16 times 2 divided by 8 equals x. Well, 16 times 2, that's 32. Divided by 8, that's 4. So x equals 4. So our intuition was correct there, that if we just multiply the top and the bottom by 2, we would get x equals 4. Okay, we're going to cut the video there. I know it's kind of like a weird part. We got interrupted in that last one, but hopefully this will work out for you guys. After this video, we're going to do the second and the third page as well.